A single weather pattern is currently producing snow in Wyoming, record heat in Boston, giant hail and strong tornadoes across Kansas, extreme fire weather in the Texas Panhandle, and flash flooding in Missouri, all on the same calendar day. 404 active National Weather Service alerts are in force. The pattern is one Rossby wave, currently locked over the continental United States in a configuration the climate research community has been describing for the last decade. The literature says this is happening earlier and more often than the climate models predicted. In 20 minutes, we will walk through the science, the data, and what comes after this wave breaks Wednesday night. Stick around for this one because it matters more than you've been told. Let's get into it. Yesterday morning at 8:40 Mountain Daylight Time, the National Weather Service office in Cheyenne, Wyoming, issued a blizzard warning. The warning covered the North Snowy Range foothills along Interstate 80, including Arlington and Elk Mountain. Blizzard conditions were occurring. Winds were gusting to 50 miles per hour. Visibility was dropping below 1/4 mile and falling and blowing snow. The alert's severity classification in the operational metadata was extreme, the highest urgency tier the National Weather Service uses for winter storm products. 3 hours later, in Boston, the same agency wrote a morning forecast discussion that contained this language. Increasing confidence of record heat today for parts of southern New England. 850 millibar temperatures are 2 to 3 standard deviations above normal, which is close to the maximum relative to the climate forecast system reanalysis climatology for this time of year. The forecaster's translation: today's lower atmosphere temperatures over southern New England are approaching the worst case value in a 46-year operational climate record. A blizzard warning and a near record heat forecast. Same agency, same morning. Different ends of one continent. And here's the part the broadcast meteorology audience missed yesterday. Both of those alerts were being driven by the same single wave of atmosphere, currently locked over the United States, doing every operational extreme the National Weather Service is built to communicate all at once. 404 active alerts were in force across the country yesterday morning. That is the total count from the National Weather Service. Every season of the year was represented. 1 blizzard warning, 12 winter storm warnings, 19 winter weather advisories, 7 freeze warnings, 6 freeze watches, 15 red flag warnings, 1 fire weather watch, 1 heat advisory with more building behind it, 21 flood warnings, 10 flood watches, 3 severe thunderstorm warnings, 6 severe thunderstorm watches, 16 wind advisories, 19 gale warnings, 27 air quality alerts, winter products, severe weather products, fire weather products, flood products, heat products, marine products. The entire annual rotation of National Weather Service alerts was active simultaneously. The state-by-state distribution made the geographic story obvious. Wyoming sat on 31 active alerts, the highest single-state count in the lower 48 outside of marine zones. Missouri was at 29, Kansas at 22, Texas at 16, California at 14, Colorado at 13. Then the East Coast load, New Jersey 8, New York 7, Connecticut 7. Every part of the country was active. The eastern third was building heat advisories. The middle third was running tornado watches and flood warnings. The western third was running blizzard warnings and red flag warnings. And here is the operational point that matters. Every single one of those 404 alerts was being driven by one piece of physics. One deep upper-level trough, currently digging into the Great Basin, one anomalously strong high-pressure feature, a Bermuda high, anchored offshore the eastern seaboard. The trough and the high were 2 halves of one Rossby wave. The wave was amplified. The amplification was what was producing the simultaneity. The single most important number in yesterday's forecast was buried in the Boston office's morning area forecast discussion. The discussion was written at 7:30 in the morning Eastern Daylight Time. The key message at the top read, "Increasing confidence of record heat today for parts of southern New England." Further down, the office wrote, 850 millibar temperatures are 2 to 3 standard deviations above normal, which is close to the maximum relative to the CFSR climatology for this time of year, suggesting very anomalous heat. That phrasing is what you need to understand. The Climate Forecast System Reanalysis, the operational climate dataset that the National Weather Service uses as its baseline, runs from 1979 to today, 46 years of operational meteorological data. 2 to 3 standard deviations above the mean in that distribution places the forecast value in the top 2.3%, at 2 sigma in the top 0.13%, about 1 in 750 observations, at 3 sigma. A National Weather Service forecaster, writing the morning office discussion, described today's lower atmosphere temperature forecast as approaching the maximum the office has ever recorded for the date in that entire 46-year baseline. The Boston office does not use the phrase close to the maximum relative to climatology lightly. They are professional meteorologists looking at operational model output, comparing it to a 4.5-decade benchmark. When they describe it as approaching the climatological maximum, they are signaling that today's forecast is in the tail of the historical distribution that almost nobody alive has personally experienced for this calendar date. To put a finer point on it, a 3 sigma event in a normal distribution happens about 1 time in 750. In a 46-year record, that is roughly once in 15 years. A 2 sigma event happens about 1 time in 44, roughly once a year if the date were random, but concentrated into the warmer months in the historical pattern. The Boston forecaster is telling the local audience that today's value is somewhere between those 2 reference points and pushing toward the higher end. Most people in southern New England have never experienced what is being forecast for today for the month of May. The data set the forecaster is using does not have a meaningfully larger sample. This is at or near the edge of operational experience. The forecast values themselves translate cleanly into the kind of numbers that show up on thermometers across the mid-Atlantic and southern New England today. The 850 millibar temperature forecast for today is 18 to 20 degrees Celsius. That's 64 to 68 Fahrenheit at 5,000 feet of altitude. When that air mass mixes down to the surface, it gets compressed adiabatically and warms by about 27 degrees Fahrenheit. The surface temperatures end up in the mid-90s at the cool end and the upper 90s at the warm end. The 925 millibar forecast of 24 to 26 degrees Celsius, 75 to 79 Fahrenheit at 2,500 feet, confirms the same picture. The Boston office is forecasting mid-90s away from the south coast and potential for upper 90s in the Connecticut River Valley. The Mount Holly, New Jersey office issued a heat advisory at noon yesterday for the Pennsylvania and New Jersey urban corridor. The office described the event in their morning discussion as unusual and potentially record-setting early season heat through tomorrow. Temperatures 10 to 20 degrees above normal, low to mid-90s, Monday through Wednesday. The Mount Holly forecast added a clinical detail that matters for what comes next. The area is not acclimated to this kind of heat yet. The first heat event of the season, the one happening today, kills more people per degree of departure from normal than the 7th or 8th event of the season because the human body has not yet completed its 2-week acclimatization curve. The Baltimore-Washington office is forecasting today's highs well into the low to mid-90s with a few upper 90s possible across the urban corridor in the central Virginia Piedmont. The New York City office has a Wednesday forecast high of 94 degrees Fahrenheit at Central Park, despite the model's known bias toward underforecasting ahead of cold fronts. The heat risk forecast for today rates major across the mid-Atlantic through New England, a designation that the National Weather Service reserves for events with elevated mortality and morbidity potential, particularly for unacclimatized populations. May major heat risk in the Northeast happens roughly once every 5 to 10 years. Today is one of those days. A Rossby wave is a planetary scale undulation in the mid-latitude westerly winds. It's produced by the combination of the Coriolis effect on air, moving across the rotating Earth, and the temperature gradient between the equator and the pole. In their normal state, Rossby waves progress eastward across the hemisphere at roughly 15 degrees of longitude per day, about the distance from Boston to Detroit every 24 hours. They have modest amplitude. Sometimes they amplify. When they do, they slow down, develop large meridional excursions, and lock into place. The same regions sit under the same troughs and the same ridges for multiple consecutive days. That is the state the wave is in right now. The trough is over the Great Basin. The ridge is anchored offshore the east coast. The trough is mechanically coupled to the ridge. They are 2 faces of one configuration. Cold air flowing down the backside of the trough is what produced the Wyoming blizzard yesterday. Warm southerly air being pulled up the front side of the ridge is what is producing today's heat dome. The plains tornado outbreak is the trough's eastern flank, ejecting energy into the warm sector ahead of it. The southern high plains fire weather is the descending air on the trough's backside, warming and drying adiabatically as it comes down off the southern Rockies. The flash flood threat in central Missouri is the warm sector's moisture being lifted over the warm front that runs across the lower Midwest. Same wave. All 5 faces. The technical name for the configuration is quasi-resonant amplification. The concept was first described in detail in a 2013 paper by Vladimir Petukov and colleagues in the Proceedings of the National Academy of Sciences. The follow-up by Kai Kornhuber and a team of climate scientists in 2020 in Nature Climate Change, titled Amplified Rossby Waves, Enhanced Risk of Concurrent Heat Waves in Major Breadbasket Regions, identified the resonance modes, wave number 5, 6, and 7, that produce the kinds of synchronized regional extremes we are watching today. When the wave is in one of those modes, the probability of concurrent heat extremes across geographically separated regions increases by up to a factor of 20. The Kornhuber 2020 paper was a starting point. The follow-up that matters more for understanding what comes next was a 2023 paper in Nature Communications by Kornhuber and a different set of collaborators. The title was Risks of Synchronized Low Yields Are Underestimated in Climate and Crop Model Projections. The argument was that the climate models being used to project the next 20 years of warm season weather have structural biases that cause them to systematically underestimate how often this kind of wave amplification will happen. The mechanism behind the model bias is the upper-level jet stream. The models tend to make the jet slightly too zonal, too west to east, and that means the waves don't amplify enough in the simulations. When you compare the model output to the observations of the last 2 decades, the observations show more amplification and more synchronized extremes than the models predicted. The current generation of climate models, the CMIP6 suite, which is the standard reference for the most recent IPCC assessment, is now considered to be underpredicting events like today. How much underpredicting matters? The models say events like today should happen once every 10 to 15 years. The observations of the last decade say closer to once every 3 to 5 years. The disagreement is what makes this an open research question. The next generation of models, CMIP7, is being developed now and is expected to do better. They are not expected to do perfectly. The gap between model and observation is narrowing, not closing, which means days like today, with 5 operational extremes on one wave on one calendar date, are happening more often than the climate projections say they should. And there's a second paper worth bringing in here because it explains the persistent side of what is happening. A 2021 Water Resources research paper by Won-Sun Han and collaborators established that low phase speed Rossby wave packets are statistically associated with persistent regional drought. Slow-moving high-pressure features sit over the same regions for weeks. The current Bermuda high is doing exactly what that paper said low-phase speed features do. It is anchored offshore the east coast. It is not moving. It is trapping warm continental tropical air over the east coast for multiple consecutive days. That is what makes today's heat last through Wednesday rather than peak and break. The wave did not amplify in a vacuum. It amplified into preconditions that have been building for months. The first precondition is the drought across the southern plains, the southwest and the southeast. The same network we covered last week. The worst spring drought on the modern instrumental record going back to 1895, with the Palmer Drought Severity Index for March 2026 at negative 7.85, and for April at negative 7.56, exceeded only by the bottom of the Dust Bowl in 1934. 44% of the contiguous United States is rated D1 or worse drought as of last week. The land surface across more than half the country is dry. A dry land surface matters for a heat dome because of a piece of physics called soil moisture atmosphere coupling. A 2019 paper by Diego Morales and collaborators in the Proceedings of the National Academy of Sciences established the quantitative effect. Under dry land conditions, the likelihood of extreme heat increases by about 30% compared to wet land conditions. The mechanism is straightforward. Solar energy hitting the surface has to go somewhere. Wet soil evaporates water and releases the energy as latent heat in water vapor. Dry soil has no water to evaporate, so all the incoming energy comes out as sensible heat. The air gets directly hot. The Dust Bowl heat records of 1934 and 1936 were partly produced by this mechanism. Today's eastern heat dome is being amplified by the same one. The second precondition is the aerosol unmasking pulse documented in a 2023 paper by James Hansen and collaborators in Communications, Earth, and Environment. The International Maritime Organization sulfur cap that came into effect in 2020 removed a third of the aerosol load over the North Atlantic shipping lanes. Sulfate aerosols reflect incoming solar radiation, which cools the surface. Removing them removed that cooling. The Hansen paper attributes roughly 0.05 degrees Celsius per decade of additional warming acceleration to this effect. The warmer North Atlantic is what is anchoring the Bermuda high in place today because warm sea surface temperatures favor stronger and more westward extended high pressure features. The third precondition is the El Niño Southern Oscillation transition. The Oceanic Niño Index is at positive 0.11 and trending warmer. The NOAA Climate Prediction Center issued an El Niño watch with an 82% probability of onset by July. Transition states historically favor amplified ridging east of the Mississippi. All three preconditions are operating in concert. The wave needed only a trigger to amplify, and the trigger was the upper trough ejecting out of the Pacific Northwest. Today is the result. The Storm Prediction Center issued a Day 1 moderate risk yesterday morning for central and northeast Kansas, southeast Nebraska, and far northwest Missouri. A moderate risk is the fourth tier of the 5-level SPC risk system, issued on roughly 4 to 6% of all Day 1 outlook days historically. The narrative was direct. Numerous severe thunderstorms are expected this afternoon and evening across the south central plains and mid-Missouri Valley. Supercells capable of producing very large to giant hail, 2 to 4 plus inches in diameter, and multiple strong to intense tornadoes are most likely from central Kansas and southeast Nebraska into Iowa and northwest Missouri. The hail forecast for 2 to 4 plus inch diameter places those stones at softball sized at the upper end. The tornado language, strong to intense, is operational vocabulary for tornadoes rated EF2 and higher on the enhanced Fujita scale, with wind speeds of 111 miles per hour or above. Severe thunderstorm. Watch 220 was active across central Illinois, northern and central Indiana, Michigan, and the southern Lake Michigan Marine Zone, covering Chicago, Indianapolis, Fort Wayne, South Bend, and Lansing. The robust thunderstorm initiation window was forecast for 1 in the afternoon to 5 in the afternoon, Central Daylight Time. By 6 p.m., the line of storms was congealing into a squall line that pushed east through the night. The driver was the same trough doing all the other work yesterday. As the wave's western trough digs into the Great Basin, its eastern flank ejects short waves out of the Rockies and into the Central Plains. The southerly low-level jet ahead of the trough pulls warm, moist Gulf air northward into the warm sector. The temperature contrast between the warm low levels and the cold mid levels produces the instability. The same Dodge City, Kansas morning sounding that produced the convective available potential energy yesterday was showing 9 degrees Celsius per kilometer of mid-level lapse rate, among the steepest values you see in the Central Plains during severe weather setups. The wave that put a blizzard warning over Interstate 80 in Wyoming was also putting a moderate risk over Topeka. Same wave, different face. The storm prediction. Center Day 1 fire weather. Outlook yesterday contained 3 risk categories live simultaneously: elevated, critical, and extreme. The extreme tier is the highest non-special emergency designation the office issues. The extreme footprint covered the southern high plains, the Texas Panhandle, the Oklahoma Panhandle, the eastern third of New Mexico. 15 red flag warnings were active across the country, plus 1 fire weather watch. The mechanism behind the extreme tier is the same trough yet again. Strong westerly winds were descending down the backside of the southern Rockies onto the high plains. As the air descended, it warmed adiabatically, about 10 degrees Celsius of warming per kilometer of descent, and dried correspondingly because the absolute moisture content of the air did not change, but the temperature increased. The Texas Panhandle hit 100 degrees yesterday afternoon, with relative humidity in the single digits. The energy release component for the date, the National Fire Danger Rating System metric combining fuel moisture, temperature, humidity, and wind, was running at the 90th percentile of historical values for the date across the corridor. The fuel state is what made this dangerous. The southern high plains has been in drought for most of the last 6 months. The grass and rangeland are dormant or dying. Live fuel moisture content has dropped to levels that fire managers normally associate with mid to late June, not mid-May. 6 weeks ahead of climatological schedule, the corridor is operationally indistinguishable from peak fire season. The drought we covered last week is still loaded under it. The waves descending air, on top of cured fuel, with strong wind and single-digit humidity, is what produced the extreme tier yesterday. Today, the cold front begins moving south into the corridor and conditions will moderate. That window of operational vulnerability closes by tomorrow. The mechanism that opened it does not. The cold front arrives tomorrow afternoon. The eastern ridge weakens. The Bermuda High retreats offshore. The wave's amplitude drops back into the normal range. By Thursday, highs in the northeast are forecast to be 15 to 20 degrees cooler than today's peak. The Friday through Memorial Day weekend forecast is for cool, near-seasonable temperatures. This wave is over by the holiday weekend. What comes next is the question. The Climate Prediction Center's June through August 2026 outlook continues to favor above normal temperatures across most of the country. The El Niño watch is in effect for the summer transition. The atmospheric ENSO signal has not yet coupled, but the literature says once it does, the wave configurations that favor eastern ridging are likely to recur. The Kornhuber 2023 paper says climate models underestimate how often these patterns will happen. The observations of recent years say they happen more often than the models predicted. The next configuration is on the horizon. It may be a week away. It may be a month away. It will not be longer than that. The signature of the next event will be the same. A deep western trough digging into the Great Basin, an anomalously strong Bermuda high parked offshore the east coast, concurrent extremes across geographically separated regions, 400 plus active alerts spanning every season of the year in the same calendar day. The mechanism is known. The frequency is increasing. We will be watching for the early signal. The position of the next Bermuda high by next weekend, the depth of any new trough digging into the Pacific Northwest. If both come back together, the pattern loads again. If they do not, we get a couple of weeks of seasonable weather before the next attempt. The atmosphere is not random. The next pattern is already on the model runs. We will be tracking it as it develops.